All right, last section. 81. Given set of figures form a pattern. Which expression can be used to determine the number of small triangles in the nth set? So this is a fancy way of saying, what's my equation without an equal sign? So I kind of think about it as first, second, and third to help me set up a little table. So we would use X, Y. They're going to use N instead of X, the same sort of thing. So then I have 1, 2, and 3, and then I want to count the number of small triangles in there. So I have 1, 2, 3, 4, 1, 4. And then that one already has 4, 5, 6, 7, 8, 9. And then 9, 10, 11, 12, 13, 14, 15, 16. Okay, so I'm going to use that, and I'm going to use stat to figure out which one I'm going to need. So I'm going to use stat calc. So I kind of look, A's linear, B's quadratic. I can't really tell with the parentheses, so let's just go ahead and get rid of those. So I would distribute out that n, so that would be n squared plus 2n, and then plus 1 on the n. Okay, so yeah, that one's quadratic. And then I have exponential, because I got that n in the exponent spot. And then last one, I got to distribute again. 2n times n is 2n squared. 2n times 1 is 2n. Okay, so that one's also quadratic. So I got to figure out, is it quadratic, linear, exponential? And then I also got to figure out which one it is. But thankfully, since I already distributed that, it's going to look just like what's going to show up on my calculator. So if we go to stat and we type in the numbers we got, 1, 2, 3, and 4, 9, 16. I need to also make sure my diagnostics are on, so I'm going to make sure that I go to mode, go to the very bottom, and make sure that stat is turned on so that I have diagnostics on, stat diagnostics. So then when I go back to stat calc, I'm going to try 4. Let's see if it's linear. R squared is 0.9908. Ooh, maybe. Okay, so linears, its R squared is at 0.9908, but look at that equation. 6 minus 2 and 1/3. That doesn't match. Nope. All right, so then I go back to stat calc. I would go 5, check the quadratic, la la la, all the way down. Ooh, it's perfect. Okay, so stat gave me y equals 1x squared plus 2x plus 1. So not only do I know that it's not exponential and it's not linear because that r squared value is equal to 1, so it has to be quadratic, but after I distributed, it's going to match B. Now you can only see that is if you distribute that in out. All right, 82. Layla launches a water rocket from a 24-foot balcony for a science project. The height above the ground is given with a table below from various seconds after Layla has launched the rocket. Based on the table below, write a function below that Layla could use to model this situation. Okay, so again, function is basically the same thing as an equation. I have a table, I'm going to an equation, so I'm once again going to go back and use stat. It doesn't tell me if it's linear, quadratic, or exponential, so I'm going to want to check to make sure on that. So I'm still going to go back. I'm going to go put in my numbers. 0, 1, 2, 4, 5, and 24, 33.5, 38.1, 32.2, 21.5. Okay. So I'm going to go stat, calc, 4, all the way down. Ooh, look at that r squared value. It's definitely not linear. 0.04. We want, if it's going to be a good, strong fit for it, it's going to be really close to 1. That's nowhere close to 1, so it's definitely not linear. Stat Calc 5 for quadratic. Ooh, look at that. 0.99999. Hard to get better than that. Pretty sure that's it. So then this one, it doesn't tell us to round to. Let's just take it to the nearest tenth. So I'd have y equals negative 2.5 x squared plus 12.1 x plus 23.95. That 5 is going to tell me to round up, so I'm actually going to write 24 because that 5 would round up the 9 to whole number on it, so you do 24. All right. 83 and 84. Table below shows the height and shoe sizes of several people. What is the correlation coefficient? Is it a strong or weak, positive or negative correlation? So correlation coefficient is the R whenever we have it. So again, you have to have diag on. So you have to have that turned on in order to see it. And sometimes if your X values are in order, you can kind of see if it's increasing or decreasing, so you can see if it's positive or negative. But if I look here at this table, it's not in order, so I can't tell. So I've got to use stat. So I got 10, 8.5, 9, 12, 10.5, and 11. And we'll go to other Y values, 70.5, 67.5, 68.5, 74, 71, 72. Okay. Stat, calc, correlation coefficient when we're dealing with this, we're only dealing with our linear, so we're going to go to 4 all the way down. All right. So my correlation coefficient is 0.998. So I know it's going to be positive because my R squared value is positive, or my R correlation coefficient is positive, but I got to decide if it's strong or weak. So when we're dealing with strong or weak, I kind of think about it as, even though I go from -1 all the way up to 1, I kind of think about it as from 0 to -1 to +1. The negative and tells me, well, that it's a negative coefficient. Positive tells me, well, that it's a positive coefficient. But the 0 to 1 tells me if it's weak or strong. So it doesn't matter if it's closer to -1 or +1. If it's really close to 1, then it's going to be your strong correlation. So if I'm looking at 0.998, that's really close to 1. So this is going to be a strong positive correlation. 85. Clarence is, Clarence is training for a marathon. He recorded the time he ran and the total distance each day in the table below. What is the approximate rate of change of the distance with respect to time? Okay, so keyword in here, rate of change, which means slope. So we're trying to find the slope for this table. That means, once again, I'm headed back to stat. So I'm going to go put this in. 4, 6, 10, 12. Don't want those. 6.3, 9.5, 15.8, 19. Don't want those. All right. Stat, calc. I'm dealing with linear because linear, we're dealing with slope, would be linear. And I get the equation y equals 1.585x minus 0.03. So this means that we're looking at mx plus b. So here's my slope. Now it does have the word approximate on it. So that means I don't really know what they're rounding it to. So since we did it earlier, I could take it to 1.6 and round it to the nearest tenth. But realize that they could round it all the way to 2, or they could round it to 1.59. All of those are technically answers. Depends on what the answer choices are. Who knows? So then we have those two other blanks. Blank per blank. Rate of change is the same thing as saying the change in y over the change in x. So a little triangle means change. So if I'm looking at x and y in my table, I'm looking at y per x. So miles per hour. If I could actually spell hour. Great. Okay, 86 through 91. We're looking at matching the correlation coefficient to its description. So again, this is that little graphic I did on the other page. 0 to either -1 or +1. If it's a -1, it's a negative correlation. If it's a +1, it's a positive correlation. If it's super close to 0, then it's weak. If it's super close to 1 or -1, then it's strong. So I kind of use 0.5 since it's right in the middle to tell me if it's weaker or stronger. So let's look. R is equal to negative 0.97. So I know it's a negative correlation, and then it's super close. It's definitely more than 0.5. So it's going to be super close to 1, which means this is going to be a strong negative correlation, or C. R equals 0.85. Okay, so again, that's positive, and it's greater than 0.5. So this is a positive, a strong positive correlation. So A. R equals positive 0.21. So positive, and 0.21 is less than that 0.5, so that means it's going to be weak. So a weak positive correlation, which is B. Okay, 89. R equals negative 0.33. So it's negative, and then it's less than 0.5, so it's going to be weak, which means this is a weak negative correlation, or D. And then 90, R equals negative 0.91, so a negative correlation, and it's definitely greater than 0.5, super, super close to 1. So that would be a negative and a strong negative correlation. So that would be C. R equals negative 0.002. That's super below 0.5. That's super, super close to 0. So it's a negative, and it's super close to 0. So it's a weak negative correlation. B. Almost there. 92. Which function represents the relationship between x and y shown in the table below? We got table, we got the first one that's linear, the second one that's quadratic. Ooh, let's look at the third one. 3 parentheses x minus 1. So if I take and go ahead and do distributing, 3 times x is 3x. 3 times -1 is -3. Okay, so that's a linear one as well. And then I got d, 3 times x squared is 3x squared, and 3 times -1 is -3. Okay, so I've got linear and I've got quadratic, so I got to check both of those when I do it. But since once again I'm going from a table to an equation, I'm using stat. So then go back to stat. We got all sorts of numbers to put in. So -2, and then -1, and then 3, 4, 5. All right, -9, -6, 6, 9, 12. Oops, 12. Okay, so then stat, calc, check 4 for linear. Ooh, not only is it a perfect fit, so I know that the quadratics are out, so B is out, and since I went ahead and did my distributing, D is out, but since, again, I already did my distributing, when they gave me y equals 3x minus 3 from stat, that shows me that it's C. So if you do that distributing first, it's going to exactly match what your calculator does. Last question, you're finally there. Write an equation for the linear relationship in the table below. Okay, so again, I'm looking for an equation. Ooh, and they even tell me it's linear, so that means I only need 4 at my stat calc menu. All right, stat, enter, clear these out. And then I get 5, 8, 11, and then 360, 405, 450. All right, stat, calc, it already told me it was linear, so I'm clicking 4 all the way down. Perfect. So that gets me y equals 15x plus 285. All right, guys, that's the very end. You are done with the review if you went in order. So good luck on your final. Remember that this being complete is 10 points on your review, and I will see y'all soon. Bye.